Okay, my question is, an electric field is produced by an object of charge 10 to the negative 5 coulombs at location 0. A ball of charge 10 to the negative 4 coulombs is placed at location 100 meters and weighs 0.1 kilograms. Calculate momentum and position of this ball through 2 iterations of a time step of 0.5 seconds. And a note is that the field is produced by an object of much greater mass than the ball, so can be considered immovable. And this is to help with the calculations to make them simpler. So, since the two objects have both have positive charges, they want to move away from each other. So the field coming from this object wants to push the ball away in the positive direction, which is nice. So we first need to calculate the initial force felt by the ball. And so we use electric force, which is equal to a constant times the two charges times the distance in between them, which works out to 9 newtons. And then calculate the change in momentum. We know initial momentum is 0 because initial velocity was 0. And so we also calculated the force, and we plugged that in and times that by the time. And the final momentum works out to 4.500 kilograms meters per second. Okay, so to find position, we first need to find our velocity, which is, we use momentum over mass. To do that, 4.5 kilograms meters per second over 0.1 kilograms, which equals to 45 meters per second for V final. We know our V initial was 0, and so we can now use our V average equals V initial plus V final over 2, because we're assuming the force was a constant, so acceleration was also, and that lets us use this equation. Anyways, average velocity works out to 22.5 meters per second, and we set that equal to our change in position over time. And so we know our initial position and our time and average velocity, so we can solve for final position, which works out to 12.250. So our final position works out to 12.2500 meters. Okay, iteration number 2, we use the same force calculation, but now the distance between the two objects is greater, so our force is smaller. That 6 times 10 to the negative 2 newtons. And then our final momentum from our first iteration becomes our initial momentum. So we have that, we have our new force calculation and the change in time, and so final momentum works out to 4.5300 kilogram meters per second, only slightly bigger than our initial momentum because the force was so small. Calculate our position, we first find our final velocity using momentum and mass, works out to 45.3 meters per second. We average that with the initial velocity, and so that works out. So the initial velocity was the final velocity of the last iteration, and so that number works out to 45.2 meters per second. And then we equal that, or we set that equal to the change in position over time, and we solve for final position, which turns out equal to 34.9 meters.